Okay, now in the reduction, that is addition of hydrogen. Okay, first of all, we are going to do addition of hydrogen in the presence of number one, addition of hydrogen in the presence of sodium boron hydride NaBH4. Sodium boron hydride. That's it. Also, you can write the same thing. Addition of hydrogen in the presence of sodium boron hydride. Addition of hydrogen in the presence of sodium boron hydride. Sodium boron hydride is a reducing agent. It's a reducing agent, Ra, reducing agent. Okay, so let us see the reaction. Reaction is very easy. You take HCOOH plus you take the hydrogen and it takes place in the presence of NaBH4. Can you tell me in your general methods of preparation that I have given to you, if the aldehyde will undergo reduction, what will be the product form? Alcohol. Okay, so let us see how alcohol is formed. So now what will happen is oxygen, we already know, is electronegative in nature, and then this is the carbonyl part of the formaldehyde group. So oxygen will pull the shared pair of electrons and then develop a negative charge. Carbon will develop a positive charge. This you have learned in the polar nature of the carbonyl compound. Okay, so to the positive charge, negative hydrogen, that is hydride, will go and join here. To the negative side, positive hydrogen, that is known as proton. Positive hydrogen is known as proton, negative hydrogen is known as hydride. Okay, positive will go here because positive and negative attract each other. Negative and positive will go there, and the product is formed HC. This H is already there, and there will be a single bond here because one bond has been shifted here. And there is a oxygen here, but to the oxygen now hydrogen is added. This hydrogen. Then you have a hydrogen here already as per the formula, and now below the carbon we have another hydrogen. This is nothing but methanol. It is a methanol, and this is methanol. That is how methanol will change into methanol. Replicate the idea for the acetaldehyde. Okay, in the nucleophilic addition reaction, sometimes in the exam, nucleophilic substitution reaction, so it will give like this. Okay, nucleophilic substitution reaction is wrong. It is nucleophilic addition reaction. The nucleophile that we are going to add is cyanide from the HCN. So let's write here HCN. When it dissociates, it will give you H plus and Cn negative ion. Cn negative ion. The Cn here represents the nucleophile. Okay, so we are going to add the nucleophile in this reaction. So let us take the formaldehyde. I'm going to write out the overall reaction HCOH and then HCN will give you HCOH and then Cn and hydrogen. You can see the hydrogen is going to get added here, Cn will come down here, and then that is how you get here formaldehyde cyanohydrin. Formaldehyde cyanohydrin is the common name. It has a different IP name. Okay, so this is formaldehyde cyanohydrin. Can you write down this reaction and this reaction again? Okay, later on we'll do it. We'll see mechanism then. This is the overall reaction. We are going to see mechanism. Mechanism is important. Mechanism will tell you how the formaldehyde cyanohydrin is formed. Okay? Are you all sleeping? Yes, sir. Okay. the mechanism takes place in two steps. Step 1. In step 1, nucleophile attack. Nucleophile attack will take place. So nucleophile will attack the formaldehyde. Okay. Oh, listen here, listen here. So I'm going to write down the formaldehyde FCOH, and then I'm going to take only the nucleophile. CN, nucleophile. Okay. You know, again, the carbonyl is polar in nature. Oxygen being highly electronegative will take the shape of electron and then develop a negative charge here. This will develop a positive charge here. So negative charge of the nucleophile electron-rich species will go to the positive side here. Carbon, we have studied, carbon having the positive charge is more susceptible to nucleophilic attacks. We have learned that one. So this is nucleophile attacking the carbon having the positive charge. Now you will get an intermediate product HCO negative. There is no double bond. One of the bond has been transferred here and it has changed into a negative charge here. Okay. Then you have a CN added here and then H. This is known as intermediate compound. Intermediate compound, short-lived, okay, unstable. Short-lived like nascent oxygen, short-lived, same short-lived and unstable. So in the step 2, it is proton transfer. Proton left here. H plus is proton. So proton transfer will take place. We will take the intermediate compound. Are you all understanding?
Yes.
If you have not understood, please do let me know which step you haven't understood. So I'm going to take the intermediate compound here, IMC intermediate compound, and then transfer the proton. Proton will go and combine here and then form a product that is OH, CN and H. Formaldehyde cyanohydrin. Okay, so that is how it is formed. I'll write down the IUPAC name. IUPAC name is, to know the IUPAC name, you have to select the longest chain. So chain will be this and this will be the longest chain. So there are 2 carbons. 2 carbon means ethane, isn't it? And let us number it. Carbon number 1 because it is the terminal carbon. Carbon number 2 here. So carbon number 2 has the OH group. Now there are 2 functional group again, CN and OH. So you have to give the priority, which one is the principal functional group. So in the functional group priority order that you have learned in class 11 in the organic chemistry, CN gets the first priority. So CN will be the principal functional group. So in that case, IUPAC name will be ethane, not ethane, 2-hydroxy. The carbon number 2, there is a OH group. So 2-hydroxy, ethane. Remove the E, dash 1. This is position number 1. It is known as nitrile, not as cyano that you have learned in coordination chemistry. It will be written as nitrile. So can you write this? This is important from the exam point of view. It's a named reaction, one of the named reactions because there's a name of a person here. Candice-Zeros reaction. In the Candice-Zeros reaction, okay, 2 molecules of aldehyde. In the presence of alkali, you can say 2 molecules of aldehyde reacts in the presence of alkali to give alcohol and carboxylic acid, or sometimes it also gives you, not sometimes, basically in the reaction we get salt of carboxylic acid is the Candice-Zeros reaction. So see, 2 molecules of aldehyde, the specified aldehyde is formaldehyde and benzaldehyde. Only these 2 aldehyde can react in the presence of alkali, in the alkaline nature, to give you alcohol and carboxylic acid. So remember the product: alcohol, carboxylic acid. If you don't remember carboxylic acid, remember salt of carboxylic acid. Salt of carboxylic acid. The criteria for Cannizzaro reaction. The criteria for Cannizzaro reaction is criteria for carbon compounds to undergo Cannizzaro reaction is absence of alpha hydrogen. So absence of alpha hydrogen, you can find the absence of alpha hydrogen in the formaldehyde and in the benzaldehyde. How? Let us see. First, to understand the alpha hydrogen, you need to understand the alpha carbon. So let us try to understand the alpha carbon. Let us take a structure of the acetaldehyde. This carbon with oxygen and hydrogen serves or function as a functional group. It is a functional group. So the nearest carbon, this is the carbon that is next to the functional group, is labeled as alpha, and the hydrogens are labeled as alpha hydrogen. So therefore, in the acetaldehyde, we see the presence of alpha hydrogen. So presence of alpha hydrogen. So since there is a presence of alpha hydrogen, acetaldehyde, CH3CHO, acetaldehyde cannot undergo Cannizzaro reaction. Does not undergo Cannizzaro reaction. Whereas if you look at the structure of this formaldehyde and benzaldehyde, let us look at this structure. For formaldehyde is like this. So this itself is a functional group and does not have the alpha carbon here. So since it does not have alpha carbon, there is no alpha hydrogen. So we can say no alpha carbon, no alpha hydrogen undergoes Cannizzaro reaction. Let us look into the benzaldehyde structure. The benzaldehyde structure is like this. Look at the benzaldehyde structure. This is your functional group. The CHO is a functional group. This is supposed to be your alpha carbon. You have a double bond here, alternate double bond here. The alpha carbon does not have the alpha hydrogen. So there is alpha carbon. Alpha carbon is there, but no alpha hydrogen. So therefore, undergoes Cannizzaro reaction. Thank you. Okay, then we will look into the Cannizzaro reaction. We know that acetaldehyde will not undergo Cannizzaro reaction. Okay, will not undergo Cannizzaro reaction because of the presence of alpha hydrogen. Now in this case, formaldehyde, we will have to look into the definition. In the definition it says that 2 molecules. So we are going to take 2 molecules of formaldehyde. 2 molecules of formaldehyde react in the presence of sodium hydroxide. Then it will give you one product is alcohol. It will give you CH3OH, methanol. plus, then it will give you HCOONA. So this is your methanol. This is your methanol. This is your sodium formate. Sodium formate. Sodium formate. So in our definition, I have written that the product form is alcohol and carboxylic acid or salt of carboxylic acid. You will know. So I have written here. This is the salt of carboxylic acid, which is known as sodium formate. Sodium formate. Okay. So we will look into the mechanism how this methanol and sodium formate is formed. You have written this one reaction. Okay. The meantime, I'll write on here mechanism. How does it happen? So I'm going to take. We know the sodium hydroxide is going to dissociate into Na plus, and okay, this one we will write it here. Sodium hydroxide is going to dissociate into Na plus and OH negative ion. From here, sodium hydroxide. Okay. First, we will take the one mole. There are two molecules. First, we will take first molecule and then react. Can I have your attention now? Can I have your attention? Let's try to understand here now. We know that oxygen is electronegative, so therefore it will take a shared pair of electrons and develop a negative charge here, and then carbon will develop a positive charge. And then we already have the OH here, OH negative. So we know that oxygen is electronegative. It will pull the shear pair of electrons, develop a negative charge here, develop a positive charge here. This negative charge will go into here. And then you will get here HCO negative, then OH, and then H. You will get this intermediate compound. Okay. Then after that we will take this one here. And first step to complete. Here, this again the carbonyl group is polar in nature. It will pull the sharing pair of electrons by the highly electronegative element, that is oxygen, develop a negative charge here, develops a positive charge here. Okay. Now this will come out. Hydrolytic fission will take place. This will come out and then join here. It is coming out as hydride ion, H negative. Hydrolytic fission. Okay, not a homolytic fission. So that the shared pair of electron is fully taken. 1, 2 shared pair of electron fully taken, which means it has excess of electron indicated by the negative charge. This is known as hydride. Hydride will come and join here, not here. So therefore, a new product will be formed. I'll write here H, and in return, this will drop down. This will drop here again, come back. Okay, so I'm going to write down first this one. H, C, then double bond here. This has dropped. Double bond, then I'll write here OH straight out. It is down here, but I can write straight because hydrogen is gone. I have written straight. Okay, this portion finished. Next, here, what is going to happen is here in this case H, C, O negative, and then you have a hydrogen, and then you have a hydrogen. So you have like this. Did you understand? Anybody did not understand? Please let me know. So that I can really explain it. Yeah. Which part?